Hello friends, I am Agrawal, Assistant Professor in Civil Department, Sandipani Technical Campus, Latu. Today's topic is conjugate beam examples here. Now the learning outcomes after watching this video, student will be able to understand the concept of conjugate beam method, and also student will be able to calculate the slope and deflection by conjugate beam method. Now the theorems. So the first theorem is the shear at any point on the conjugate beam is equal, that is in sign and value, to the slope at corresponding points on the real beam. And theorem number 2 is the moment at any point on a conjugate beam is equal, that is in sign and value, to the deflection at corresponding point on the real beam. Now the steps of the conjugate beam method. The first is to determine the bending moment diagram for real beam. Set up an additional beam called conjugate beam. Then to apply the M by EI load on the conjugate beam. Next is to determine the reactions of conjugate beam. Then next to determine shear force in the conjugate beam where the slope is required in a real beam. And to determine the bending moment in a conjugate beam where the deflection is required in a real beam. Then the sign conventions here. The sagging bending moment for real beam gives the positive M by I diagram, and hogging bending moment for real beam gives the negative M by I diagram. Now positive M by I diagram means upward loading for the conjugate beam, and negative M by I diagram means downward loading for the conjugate beam. Positive shear for conjugate beam means anti-clockwise rotation of a tangent drawn to elastic curve with respect to original position at corresponding point in a real beam and vice versa. And last one is the positive bending moment for conjugate beam means upward deflection of a corresponding point in a real beam and vice versa. Now here we take example. Now this is a beam, is subjected to, suppose, is point load of 2 kN, and at center is an anti-clockwise movement like this of 10 kN. This span is 2 meter, and this also spans the 2 meter, having the constant EI. This A is B, this end is A, and this end is a B. So here find slope and deflection at free end. And EI constant. Now for this we have to draw the BMD for this. So we are drawing the separate BMD for the separate load for only this moment here. The BMD is like this. This moment create the sagging bending moment. So this is a BMD. This is a 10. So we are is 10 by EI, and this is a 10 by EI. And this is a positive. Again, bending moment diagram for this point load is now this create the hogging bending moment. That is the below the line. So 2 into 4, that is the 8. So here is 8. This is 8 by EI. So this is a hogging bending. Now apply this M by EI diagram on the conjugate beam. So we know when the cantilever beam is we have to find the slope and deflection. In that case, we have to make a fix to the free end and make a free end to the cantilever end. So here we are drawing the conjugate beam. So for conjugate beam, this is free end to make here the fix by the conjugate beam method and make a fixed end as a free. Now apply this load, both the load on this beam. So we know we are applying the sagging bending moment in the upward direction. So this is the bending moment. This is a 10 by EI and this is a 10 by EI. So this load is a upward load. This is in the upward direction. And now we are applying this hanging load in the downward direction as per the sign convention. So here is a downward load. And this is a 8 by EI. We know this distance is a 2 meter and remaining is a 2 meter. So now our aim is to find this reaction and the moment. Suppose we assume this is vertical initially. If our answer is positive, so our direction is correct. Otherwise we have to change the direction. Now we are assuming here this moment is the clockwise initially. So now the reaction is the total load on the beam. So RB. So here suppose this load is, we are considering a sigma Fi condition here is equal to 0. So vertically upward is a plus and vertically downward is minus. So this load is vertically upward, so that is a 10 into 2, 20 is upward. Then this load is the downward, that is minus 1/2 base is a 4 into height is 8. This is divided by EI and this divided by EI. And we are assuming this is upwards, that is the plus RB is equal to 0. So we can say that this RB is equal to this minus goes on right side, become the plus. So 1/2 base into height, then minus here 10 by EI into 2. So this calculation is the minus 4. Minus 4 by EI. So now we assume this direction is vertically upward, so that is wrong. So we can say that this RB is equal to 4 by EI and that is the downward. So we have to make here corrections. We change the direction. Make this in this. Now next part is the sigma MB equal to 0. Sigma MB equal to 0. So we are considering clockwise as the positive and anti-clockwise as the negative. So now here we know this MB is a clockwise, so we are considering this positive. Then this load, upward load, creates a sagging moment, so plus 10 into 2 into this distance is x bar, is 2 plus the 1, that is 3. This 2 plus half of this 2 by 2, so it becomes the 3. Then this is a minus, so minus 1/2 base, again here the EI, 1/2 base into the, this is not a, base into the height into distance. From here this x bar is to suppose this is the 2/3 of this, 2/3 of this 4. So here this 2 gets the cancel out. So this becomes mv is equal to minus 17.33 by EI. So now this is a minus, it means what you assume the direction is clockwise is wrong. So we can say that is mv is equal to 17.33 divided by EI, and that is the anti-clockwise direction. That is the anti-clockwise. So make here the corrections. So this now become is anti-clockwise in this way. This is MB. Now our aim is to find the deflection at the free end, means at this theta B. So by this conjugate beam method, so deflection at B, first we solve the slope here. So slope at B, that is equal to the shear force at B in conjugate beam method, in the conjugate beam. Now that is equal to here. Now this is shear force. So if you take the shear force, just this LHS. So from this right side, this shear force is a positive. So we can say it is a plus RB. That is equal to 4 by EI. This is 4 by EI. It means if the shear force is positive, so that is the slope is the anti-clockwise, that we have seen in the sign conventions. If the slope is the positive, shear force is positive, it means that this slope is the anti-clockwise direction. So we got here the slope at B, that is 4 by EI. Then deflection. Deflection at B, that is equal to this bending moment at B in conjugate beam method, in the conjugate beam. So we can say that is equal to the MB. And now this is a anti-clockwise. This is a anti-clockwise. It means here, as per sign convention, this create the sagging bending moment. So this create the sagging. So this is a plus. So now for this sagging bending moment, the deflection is upward. Deflection is upward. So MB is equal to the 17.33 divided by EI. So this deflection is in the upward direction. So we can delta B is equal to the plus MB, and that is equal to 7.33 if the moment is a sagging. So in that case, the deflection is in the upward direction. So this is a slope and the deflection at the free end. Thank you.